All right, welcome back. We're out in the garage, and this machine right here is a Van Norman. I believe it's a 204. Not exactly sure. Bought this back in 1987 when we were setting up the machine shop. It's one of the machines that I did keep. I did keep a PH 6000 also. Seat and guide machine, and the one machine I miss the most is the VB160 boring machine. But we did keep quite a bit of equipment. The other stuff is not on this premises, but this one's here. So what we're going to use this for is we are going to turn the drums on the 53 Golden Jubilee. I'm going to set it up on here, use a dial indicator, make sure it's running decent. Those drums have never been turned. I measured it. It's only about maybe 6 to 8 thousandths under standard inside diameter. So we're going to try to skim as little out of here as possible, because the more you open up a drum, the less area of the shoe will actually rub against the drum. So the arc changes, and what you end up with is just the center of the shoe hitting the drum. So I'm going to set it up, put a dial indicator on it, see how bad they are. If they're way out, I'm going to use them the way they are. They will work. It's just I just don't want to take too much out of them, and they are very expensive to replace. So let's get it set up, and I'll show you what I'm going to do. So what we want to do is we want to use the cups or end bells, the biggest ones we have, and we're going to squeeze the inner and the outer face between these two. And we want the two, it's not solid all the way around, it's got little fingers. We want the fingers to line up, because we don't want to twist or torque the face of that drum. We picked a center collar or a cone that's going to be big enough to line up with the center hole in the drum, and then we're going to squeeze them between it. Now, I painted the outside and the inside face of this area, just so it wouldn't rust when it's on the tractor. The tractor sits outside all the time. There's a lot of nickel in these cast iron and steel pots. They don't rust a lot, but they do rust. I'm going to come in here with a piece of sandpaper and just clean the paint off the face that rubs up against the brake shoes, so I can put a dial indicator on there. This is a vibration belt, just to take harmonics out. All right, let me go get my dial indicator with my ID. Well, actually, let's take the paint out of the inside. Actually, I'm going to move this out of the way. So this is the drum setup, and over here would be the rotor setup. first glance, it actually doesn't look that bad. All right, I'll be right back with the dial indicator, and I'll put some brake clean in there to finish cleaning up that paint. All right, it's moving about 8 thousandths. That's not bad at all. I put in a couple of positions, and it runs about the same. So I'm going to go with the 8 thousandths. So it means it's going to take at least 16 to clean it. We'll see what happens. That's fine with me. I don't have a problem with that. This is a standard nominal bore, so we'll be in good shape. Okay, so the big difference between this drum and a traditional automotive drum is the automotive drums and rotors are made of cast iron. Dissipates the heat better. They usually have fins in them. Even the drums, a lot of them will have fins in them. But because this tractor really doesn't go that fast and braking is at very low speeds, in order to make it last a lot longer, they used a steel drum. So, which makes them very expensive if you were going to try and replace them. So the traditional cutter for, I don't know if you guys can see that, for a cast iron drum is right here, and it's designed specifically to cut cast iron. What I did was, for this particular one, is I just took a piece of Momax and ground it, kind of like a traditional, lathe tool bit, very similar. I don't need a lot of back relief in here, even though I'm doing an ID, because obviously this is a very large diameter. But I honed a nice little radius on there. And this is going to do a lot better job than that cast iron cutter. Okay, so I'm going to put this in the boring bar, and we'll get ready to turn. Cutting that back radius, well, not the radius, the back pot where the shoes never touched, to make sure they don't rub the new shoes. We're just using WD-40 rather than trying to smear cutting fluid all in there. I'm taking a relatively light cut, just my first trim cut, and I'll finish it up with a nice fine cut. I'll bring you back when this cut is just about finished. This is going to take a while. Alright, well, the first pass went well. There was quite a bit of a rust ridge right out on the edge, where the shoe never ran. The moisture got to it. So I'm just going to take this bit out, and I'm just going to hone it again, make sure it didn't screw up my radius. So the rust did wreak a little havoc on the tool bit, so I touched it up, rehoned it. I only took about 3/1000. I'm going to take about another 3. I don't want to take any more than I have to out of this drum, so we'll take another pass. Gotten nice right now. The chip is just like a fine hair. Bring it back when it's done. Alright, it's finishing up right out on the end. Get a little bit of chatter right out on the end. This is the finished cut with the high-speed steel tool bit. Looking really, really good. We'll go in there with a piece of sandpaper that's mostly to take out the spiral so you don't screw the brake shoes off the backing plate. But this tractor doesn't go over maybe 10 miles an hour, so I'm not too concerned about that. But we'll sand it. All right, so we're using 180. Thought it was 150, but it's 180. Alright, we'll take it off the here and we'll take a look at it. Alright, I'm going to go over, wash it with soap and water, and we'll take a peek. Inside the back there, it looks like a lot came out, but that's just where you clean up the back so it doesn't rub against the shoe.